Well, hello everybody. Hey, sorry I'm gone once again, heading to McPherson cross country this time. Hey, here's going to be the plans for the day. I need to cover section 2-3 with you. You'll find that it's 99.9% review from your FST days. I might just change the notation that you use just a little bit, but overall the topic's going to be the same. I would like to quiz you next class though. So let's plan on doing that over domain, range. Make sure you know how to use that f of x plus delta x. Finding this right there. The delta x is really just a variable. So we'll quiz next time on that. But what I need to do today is I need to cover in behavior with you. And then if I was there, we would graph them and talk about them. When I taught it yesterday, the G1 Calc class remembered everything, so we're going to just pick the pace up on that. I need to make sure you can find x and y intercepts without the use of your calculator. And then I need to make sure you remember how to graph rational functions. It'll be review, I just got to point out a few things for you. And then the assignment's going to be out of the book today. So let me start here. Hopefully you got the correct notes right in front of you. Your very first problem should look like that. X squared minus 2x plus 1. Hey, I'm going to see what you remember here. I'm hoping that you remember x squared minus 2x plus 1. It's going to be a parabola that's opening up. Hey, now the end behavior just refers to what's happening as x gets larger and larger and larger, what's happening to the y values, and then what's happening to the y value as x gets smaller and smaller and smaller. Notation looks like this. That piece right there says, as x approaches infinity, f of x approaches something. So in this case, as my x values get larger and larger and larger, what's my y values doing? In this case, they're going up, 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 so they're approaching infinity. As x approaches negative infinity, aka as x goes to the left, what's your y values doing? They're also increasing. Now, instead of graphing it to determine the exact number of turning points, we're going to talk about the most turning points it might, or the least amount of turning points it could have. Since this is a squared function, it's going to have at least one turning point. At most one turning point, not at least, at most one turning point. If you would, go over and look at number 2. I got x to the 4th minus 3x cubed plus 2x squared plus x minus 6. All I know is since this is an even number, both my ends will be going either up or down. Since the number in front here is positive, I know the end behavior is going to be going up, up. The middle does something. We really don't care what that does right now. So in terms of notation, as x approaches infinity, f of x is going to approach infinity. It's going up, up, up. As x approaches negative infinity, f of x is also going to approach infinity. Number of turning points. In this case, I went ahead and graphed it for us. There's going to be 3. There could be at most 3 turning points in this case. It's a 4th degree polynomial, so the most there could be would be 3 turning points. Look at your number 3. Just to sketch a rough graph of it. I know since this is even, the branches both go up or the branches both go down. Since there's a negative value out front, I know it's going to go down to the left and down to the right. And like I said, the middle, we're just unsure about at this moment. Notation-wise, though, as x approaches infinity, f of x is going to approach negative infinity. As x approaches negative infinity, goes to the left, my y values are also decreasing. Number of turning points, of course, I graphed it. This one also has 3, but the most turning points that it could have would be 4. It would be 3. Always one less than your power. You can tell I'm making a video, it's early in the morning. Hey, here's your number 4. If you were to graph that, I know once again it's an even power, so they're both up or they're both down. Since this is a negative out front, I know my end behavior is going to be pointing down. Then once again, guys, the middle does something. So as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches negative infinity. I graphed it, but I know the most turning points that it could have would be 3. And then one last one on this even part. X to the 4th, it's even. The number out front's positive. I know it does something like that. Now this graph doesn't have many turning points. It almost looks like a parabola. So I know it's only got one turning point, but I know the most that it could have would be 3. For my end behavior, you already got this part figured out. That's going to be infinity. That's going to be infinity since they're both going up. So my 1 through 5, I just took care of what happens if it's an even power. On my 6, 7, and 8, I'm going to take care of if it's an odd power. So hopefully this makes sense to you. Sounds familiar. On number 6, I got 8x cubed minus 12x squared plus 2x plus 1. The only thing that really matters on the end behavior is the lead coefficient and the highest power. Since this is an odd, I know one branch is going to go up, the other branch is going to go down. In this case, since this is positive, see if this sounds familiar. It's going to be going up to the right and down to the left, and then in the middle it does something. So as x approaches infinity, f of x also approaches infinity. As x approaches negative infinity, my y values is decreasing, so approaches negative infinity. And then the most turning points that this thing could have would be 2. Number 7 is going to kind of be the same graph. 3x to the 5th, since it's an odd, I know one branch goes up and the other branch goes down. When I remember the odd function, I remember the simplest one, the snake, up to the right, down to the left, and then if there's a negative out front, I flip it. And then, like I said, it does something in the middle. So in this case, we're going to go to infinity again, and negative infinity. And then this thing only had 2 turning points if you were to really graph it. The most it could have, 4. And then my last little piece on this part, negative x to the 5th. Since that's an odd power, I know one branch goes up, one branch goes down, but it's going to be opposite from what we've been doing. This branch will be going down, this branch will be going up, and we know it could do something in the middle. So in this case, as x approaches infinity, I've got negative infinity. As x approaches negative infinity, I got infinity. When I graphed it, it had 4 turning points, and that's the most turning points that it could have. So there's what I got so far. So I left you just a little space to put some notes. I know you have a note card from Miss Colwell. I'm just going to shorten the notation up a little bit. What I know about polynomial functions, the only thing that matters is this lead coefficient. So here's what I got. If n is even, and a is positive, I know it's going to go up to the left and up to the right. That's what my branches are going to look like. If n is even and a is negative, I know my branches are going to go down to the left and down to the right. I know that if n is odd and a is positive, I know my right branch will be going up, my left branch will be going down. Then, of course, if a is negative in that case, I know my left branch is going up, my right branch is going down. So my next slide's not going to be on your notes, but here's what I'd like to do on it. What I'd like to do on this is say if a is positive or negative, if n is odd or even, and then the power that it's got to be, or at least the power that it's got to be. So in this case, since it's odd, I know that my power is odd. I know since it's opening up to the right that a is going to be greater than 0, and I know this has got to be at least a 3rd degree polynomial. I see 2 turning points, add 1 to that, so it's got to be at least a 3rd degree polynomial. On my next one, I know one branch is up, one branch is down, so it's got to be odd again. so n is going to be odd. I know that a is going to be negative. There's 2 turning points, so this thing's got to be at least a 3rd degree. It could also be a 5th degree, it could be a 7th degree. And then here's my last odd one. We know n's going to be odd. The branch to the right is going up, so I know a has got to be greater than 0. Then it's got to be at least 1, 2, 3, 4. It's got to be at least a 5th degree polynomial. Could be a 7th, could be a 9th. Then of course I got a couple of evens on this side. So in this case I know that n is even. Both branches are going up, so I know that a is going to be greater than 0. 1, 2, 3 turning points, so it's at least a 4th degree polynomial. Could be a 6th, could be an 8th. And then my last one before I move on, we know that n is even again. I know that a is negative. And if we look at its degree, it's got to be at least a 1, 2, 3, 4, 5. It's got to be at least a 6th degree polynomial. Like I said, could be an 8th, could be a 10th. You'll have a few on your assignment today in the book. They're really easy. You'll just look at the graph and you'll list those exact same things. Okay. Hey, if you would, flip down to finding the x and y intercepts. I'll take your calculator away from you on this. Of course, you can cheat since I'm not there, but I can always toss some equations at you like number 4 to where your calculator can't help you out. So you got to know how to find x and y intercepts without the use of your calculator. Hey, but here's going to be other steps. To find the y-intercept, we're simply going to let x be 0 and solve it. To find the x-intercept, we're going to let y be 0 and solve it. Finding the x-intercepts is usually the tougher one. And a lot of times it entails some factoring. The good old F word. So here goes your number 1. Without your calculator, find the x and y intercepts of the following. Well, to find the x-intercept, I'm going to let y equal 0. And if I do that, I have 0 equal x squared minus 4. You can factor that. You could solve that. I'm going to go ahead and factor it. X minus 2 and x plus 2. So it looks like my 2x intercepts are going to be at 2 and negative 2. Listed as ordered pairs, 2, 0, negative 2, 0. To find the y-intercept, I'm going to let x be 0. If I do that, I get y equal 0 minus 4, so y equal negative 4. So my y-intercept occurs at 0, negative 4. So that's all there is to it. The factoring shows up once again, but we're getting better with that. So here's your number 2. To find the x-intercepts, I'm going to let y be 0 again. So I'm going to have 0 equal x cubed minus 4x. Let me factor out an x. So I have an x times x squared minus 4. That's still set equal to 0. And if I factor again, I get x times x minus 2 and x plus 2. In this case, there's going to be 3 x-intercepts. One's going to occur at 0 because I got an x right there. Another's going to occur at 2. Another's going to occur at negative 2. In terms of an ordered pair, 0, 0, 2, 0, negative 2, 0. To find the y-intercept, let's let x be 0. And if I do that, I got 0 cubed minus 4 times 0. So it looks like I got a y-intercept also at the origin, so 0, 0. So that's all there is so far. Here's your number 3. Even though it's a radical, don't get caught up in how hard it is. To find the x-intercept, we're going to let y be 0. So 0 equal x times the square root of x plus 3. So here's my thinking. X equals 0 is going to be one of the x-intercepts. And whenever the square root of x plus 3 equals 0 is going to be my other one. Well, if I could make x plus 3 be 0, then I have my other one. So I know that x plus 3 equals 0. X equal negative 3 is my other x-intercept. So as ordered pairs, I got 0, 0. And I got negative 3, 0. To find the y-intercept, I'm going to let x be 0. So I'm going to have 0 times the square root of 3, which is 0. So my y-intercept, also through the origin, 0, 0. Here's your number 4. This would be one that the calculator couldn't bail you out on. But the steps are really easy. To find the x-intercept, we're going to let y be 0. So look at what I'm going to have. I'm going to have 0 equal 3x squared. If I let y be 0, 5xy is out of there. So minus 12. Now whatever you want to do to solve this, I'll go both ways. If you want to factor it, I got a 3 and an x squared minus 4, which leaves me at 3 times an x minus 2 and an x plus 2. Since this is a constant without a variable, it doesn't yield me an x-intercept, but I will have one at 2 and negative 2. So I've got x-intercepts at 2, 0 and negative 2, 0. If you wanted to solve this a little different, you could have added 12 and then divided by 3. So you would have x squared equal 4. And then you could take the square root of both sides. Remember to do the positive negative on that side. So you could have done that also. Here's my y-intercept. Once again, I'm going to let x be 0. And if I do that, I got y equal 0 plus 0 minus 12. So it looks like my y-intercept is going to be 0, negative 12. On to your number 5, a fraction. Big deal. To find the x-intercept, let y be 0. So I got 0 equal 4x squared minus 9 all over x plus 5. The only time a fraction can equal to 0 is when the numerator equals 0. And here's why. If I go ahead and put that over some number and cross multiplied, I'm going to have 4x squared minus 9 equal 0 times that is 0. I'm going to go ahead and factor this into 2x minus 3 and 2x plus 3 equals 0. So I'm going to get x-intercepts at positive 3/2, negative 3/2. As ordered pairs, 3/2, 0, negative 3/2, 0. For my y-intercept, let x be 0. So I'm going to have 4 times 0 squared minus 9. So I'm going to have negative 9 over 0 plus 5, 5. So my y-intercept is going to be at negative 9/5. And then my last x and y-intercept one. It looks kind of complicated, but this one's about as easy as they can get. To find my x-intercept, I'm going to let y be 0. Well, if I let y be 0, this thing's already factored for us. Don't FOIL that thing out. Don't multiply that thing out, because you'll just be making too much work for yourself. I'm going to get an x-intercept at negative 4, at positive 3, and negative 1. So negative 4, 0, 3, 0, and negative 1, 0. To find my y-intercept, let x be 0, so I'm going to wind up having 0 plus 4 times 0 minus 3 times 0 plus 1. So it looks like my y-intercept is going to be negative 12. So that's how you find the x and y intercepts. Let x be 0, let y be 0, then go to work on them. Okay, if you would. Hey, hopefully there's not a mess up in this. It froze up on me, so I paused the video and then I restarted, so hopefully we're right back to where we ended. I just finished up the x and y intercept, so if you would, scroll over or jump down to your example that says x squared minus 12x minus 12 all over x minus 4. If you would, this will take a second, but if you would, go ahead and graph that, because I need you to see something in your calculator. And I'm not insulting your intelligence, so parentheses x squared minus x minus 12, close your parentheses, divided by parentheses x minus 4. Otherwise, it's going to give you some kind of hyperbola. So graph that, and I'm hoping that once you hit graph, I'm hoping that you just see a plain old line on there. Hoping that you just see a plain old line. Okay. Now that's kind of the graph, but it's not all the graph. Keep that on your calculator for a second. Now let me come over and look at this now. I'm going to factor x squared minus x minus 12. So I got x minus 4 and x plus 3 over x minus 4. Let me talk about the domain for just a heartbeat. If I asked you what values of x can you not use, hopefully you tell me that x could not be 4. So something's happening at 4. So if you would, back on your calculator, if you will, go trace 4. And if you go trace 4, it shouldn't show you a y value. Here's how come. Notice that I can divide out these x minus 4s. Whenever you can divide out something like that, that means there's going to be a hole in your graph. That should sound familiar from last year. There's going to be a hole in your graph. Your graph's going to look like what's left, the x plus 3. So on your calculator, you should see a line starting at 3 with a slope of 1. But there's a hole in the graph at whenever x is 4. To get the exact location of the hole, plug in 4 into what's left. 4 plus 3 is 7. So there's a hole in your graph at 4, 7. So here's what your graph's going to technically look like. Over at 4, 7, there's a hole in my graph. Otherwise, it's going to start at 3 and have a slope of 1. And then let me graph that. Okay. Hey, then either label the hole in your graph or make sure it's labeled off to the side. But moral of that story, if you can divide something out, there's going to be a hole in your graph. Okay. Look at your next one. We'll sketch most of this one without your calculator. So I got f of x equal x squared minus 9x all over x. Well, if you look at x squared minus 9x, it'll factor. I'm going to factor out an x, which leaves me an x minus 9 over an x. Pause just 1 second. Something happens at 0. Because 0 is not in my domain. So there's either got to be a hole or an asymptote at 0. To tell which one it's going to be, I can remove these x's. I can cancel them out, leaving me x minus 9. So I know when I graph this thing here in a second, it's going to look like the line y equal x minus 9. That's what my graph's going to look like. But since I removed this, there's going to be a hole in this graph when x is 0. To get the exact location of the hole, plug 0 back into what's left and get negative 9. So when I graph this thing, I know at 0, negative 9, there's a hole in the graph. I know it should start at -9. There's that hole, and it has a slope of 1. And then when we go to graph it, and then I've got my hole labeled right there. So once again, guys, if you were to graph this and go trace 0, you would see no y value once again. What do I do to you next time? Almost the same thing. I start calling this number a limit. And it looks like I just have 2 more. Sketch a graph of x minus 3 over x squared minus 9. Well, do any factoring that you can. So the numerator stays as x minus 3, the denominator x minus 3, and x plus 3. Hey, so something that I know, something happens at positive and negative 3. Something happens at both of those. Here's how you tell which one. The one that you can cancel out, that's where the hole is going to be. So there's going to be a hole in the graph. It's going to occur when x minus 3 equals 0. My hole is going to occur with the one I canceled out. My hole is going to occur at x minus 3 equals 0. So there's going to be a hole when x equals 3. Hole then when x equals 3. Now let me come back up here. I'm going to cancel out those x minus 3's, which leaves me 1 over x plus 3. To get the exact location of this hole, plug this 3 right back up into here. The exact location then is going to be at 3, 1/6. The thing that we couldn't remove, look at what's left. 1 over x minus 3. Well, I can't allow you to use a negative 3, so there's going to be an asymptote at x equal negative 3. So here's what this graph's going to look like. At x equal negative 3, there's an asymptote. I know there's a hole at 3, 1/6. The only other thing I'm going to go find, because it's really, really easy, I'm going to find the y-intercept. Because to do that, I'm just going to let x be 0. If I let x be 0, I've got negative 3 over negative 9. So I also know it has a y-intercept. Okay. And then the graph, you could peek at your graphing calculator now. The graph's going to look something like this. The key things I needed out of that, though, guys, I needed the exact location of that hole. I needed there's an asymptote, and then have the obvious points on there, in this case, the y-intercept. Then it looks like I have one more coming your way. Here's my last one. I got f of x equal x minus 4 over x squared minus x minus 12. So I'm going to go ahead and factor that into x minus 4 and x plus 3. So what do we know? We know that x cannot be 4 or negative 3. X cannot be 4 or negative 3. The hardest part, though, is deciding which one is the hole and which one is the asymptote in this case. Well, I'm going to cancel out the x minus 4's, leaving me 1 over x plus 3. The one I canceled out is the hole. So there's going to be a hole because of the x minus 4. I'm going to set that x minus 4 equal to 0, so I have a hole at 4. So there's going to be a hole in my graph when x is 4. To get the exact location, plug 4 right back up into there and get 1/7. The one that you cannot get rid of, this x plus 3, you can't get rid of that. So there's going to be an asymptote at x equal negative 3. The only other obvious thing I'm going to do, the y-intercept. If I let x be 0, I've got negative 4 over negative 12, which yields me 1/3. So to go graph this, I know I got 4 1/7. I got an asymptote over here at negative 3. I got an asymptote there. I know I got the y-intercept at 0 1/3. And then my graph's going to look something like that. So that's the main part of the lesson. The hardest part, guys, is deciding when it's a hole and when there's an asymptote. On this slide, I have the assignment. I'll also do this to you, though. Pretend that you saw something like this, just to try to help you out on when there's a hole, when there's an asymptote. Pretend that you had something like that. The ones you can cancel out, there's going to be a hole when that point equals 0. So I could cancel out this x plus 3. So I know that there would be a hole at x equal negative 3. Because x plus 3 equals 0 equals negative 3. These x minus 2's would cancel out. I know there would be a hole at x equal 2. Because x minus 2 equals 0 is 2. The one you can't get rid of, there's going to be an asymptote. So I know there's going to be an asymptote at x equal negative 5. So that's the hardest part of the whole lesson, because we confuse which is which. Hey, now your assignment's out of the book. It's really a pretty easy assignment. I tried to type my directions since I wasn't there to say them out to you, but I got you doing numbers 7 through 15 all. And guys, what it is, it's just matching. You look at the graphs, match them up. Don't compare the back of the book. I want to say the back of the book was wrong on a couple of these. They may or may not be, though. Try to do them without your calculator, thinking about the in behavior, the in is even, the even or odd, how it opens. Now on 21 through 26, they're going to give you a graph. What I would like for you to do is tell me if A is positive or negative, if N is even or odd, and then the degree is at least, so your number of turning points plus 1. I do have you graphing 4 problems today. I'm going to have you graph number 27, 31, 39, and 40. So do your note card graphs. I got graph paper if you need some. I hope to remember to leave some with the sub. Name the intercepts, the asymptotes, or any holes. So make those good graphs. And then on 42, there's a problem there I don't think you'll have much problems with. On 51 and 61, they have you going through and doing some things. If it says graph, that'll just be done on your graphing calculator. Those will make sense once you get to there. So, and then number 63 is graphing. So if it says graph other than 27 through 27, 31, 39, 40, if it says graph, otherwise you'll just use your calculator. Otherwise, those will be the good ones. So get that assignment written down. You can hit pause, whatever you need to do. I'll clean up any questions when I see you on Monday. Good luck and have a great weekend.